Hey, this is the first video that's part of ADCS or Active Directory Certificate Services Attack Series. We'll walk you through various Active Directory Certificate privilege escalation methods, showcase how to detect, exploit, and remediate those issues. So here I have my lab environment I've set up, which has Scala VM, which will be used for most of our attacks. We have our domain controller, so in our domain, and we have a Windows 2025 server that's joined to the domain, and I installed ADCS feature on this server, so it's gonna be our enterprise CA server that's responsible for issuance and revocation of the certificates. So in this first video, we'll look into escalation 1 or ESC1 for short. This privilege escalation allows us to authenticate as any user in the domain when certain conditions are met, which we'll look into later. But since this is the first video of a series, let's do a quick overview of how ADCS works and what it is. So first we have our client, which is user computer, and generates a public-private key pair they'll use. Second step is client sends a certificate sign request or CSR to the CA server. And CSR usually contains the following: the template name, which is, think of it as a blueprint. It defines what certificates can be requested from the CA and how the certificate is going to be used. So on the CSR, we also have our subject, which is our user, in this case Marvel and the user. Marvel is the domain in this environment. Then we also have a EKU, which stands for extended key usage. This defines what the certificate is going to be used for. There are various EKUs that can be defined. In our case, this client authentication, which means the certificate can be used for authentication to domain controller or any computer, for example. And we have our public key that user sent. Step number 3, enterprise CA does template and enrollment rights verification. So basically it checks, hey, does this template that requested let me in exist? And can our user actually enroll the template? So here I have our template let me in, which has EQ any purpose, which means that's fine. It can give certificates for anything. Enroll permissions, we have domain users, which means, yeah, anyone can enroll to the certificate, which is very insecure, but we'll cover it later. And there's also this thing called approval. Sometimes you can set manual approvals before certificates are issued. In our case, it's set to no. So yeah, it compared CSR and templates, like, yeah, everything matches. So it generates a certificate and signs it using CA's private key. Now the certificate is sent to our client, which can be, again, user computer, and client just stores it in the certificate store and can start using it for the EKU it requested, which in our case is client authentication. So this high-level overview of how ADCS actually works. So now let's dive into ESC1 privilege escalation and try to compromise the main admin account. We'll use a tool called Certipy. I'll link it in the description down below. So this basically, think of it as a Swiss Army knife to exploit ADCS and various ESC escalation attack paths, which exactly what it says. There's 16 of those, ESC1 through 16, and hopefully throughout the series I'll demo most of this. I'll already create a vulnerable template that's vulnerable to ESC1, but let's go to their wiki, and they have explanation for each escalation path and what requirements need to be met for it to work. So here we have an early supply subject, which means any user, when they request certificate, they can supply a subject alternative name, which is also going to be used by that template. And this can allow attacker to inject the victim's identity. For example, we can specify a domain admin, and basically this way we'll impersonate a domain administrator with our request. Authentication EKU, which is extended key usage. Basically template, as we looked before, has to have client authentication or one of these others, smart card, PKI need, or any purpose, which we'll examine our vulnerable template just in a moment here. Permissive non-rights, basically our user needs to have permissions to enroll. As I showed in our demo, user that requested the certificate has to have enroll permissions, otherwise it's not gonna work, which I'll show how to set and disable it in the template at the end of this video. And no effective security gauge, which means there's no manager approval required. And the enterprise CA will just issue the certificate. So yeah, these are the requirements. Let's dive into the exploitation. So first we'll use netexec ADCS module, which can be used to enumerate domain in general to see if there are any certificate authorities, templates, like where the CA is, on what server it is. So, we'll use netexec NXC, have to specify LDAP, IP of our domain controller, and we need valid credentials for any domain user. It doesn't matter if the user has privileges or doesn't. We just need any user. So specified our module, which is ADCS, and run it. And we can see that this domain has a certificate authority, and the enrollment server is gotham.marvel.local, and our certificate authority is called batman.ca. So now let's look for vulnerable templates using Certipy. So this is the command. We need to specify Certipy find, tells it to look for templates. We give it -vulnerable flag to look for templates that are vulnerable to any of the escalation paths, ESC1 through 16, and specify our username, our password, and we need to give it domain controller IP address. So let's click run. And it's gonna try to query all templates, which all users in the domain can query those by default. There are no restrictions. That will scale up our output and pipe it to JQ to make it all pretty. And here we have it, ESC1, and all supply subject and template allows for client authentication. So going back to our overview here, so I think this shows it better. So our first check needs to be that in our supply subject, which means our user can specify the subject alter name or SAN. And here we have it in here, SAN equals 2. Next check is that it can be used for client authentication or any purpose, and inside the ETU, and check client authentication, any purpose specified. And we need to make sure there's no manager approval on the template, and the require manager approval is false, which means there is no approval that needs to happen. So I have 3 out of 4. And last check is that our user needs to be able to enroll the certificate template. And we have that domain users, which is the default group, and any domain user as part of domain users. And that group can actually enroll the certificate, so we have 4 out of 4. So we can go ahead and exploit this vulnerability and escalate our privileges. So first, let me show that our user is actually just a normal user that doesn't have any extra privileges or anything. So on my DC, I'll go to find. Our user is P Parker. And I'll go to member of, and he's just a member of the main user, so there are no extra privileges, nothing. Just a regular user. Okay, now let's try to exploit the vulnerability. This is the syntax. Request. Oh, you have the command. So let's break it down. What's happening here. So request, which is tells Certipy to request certificate. Our user, our password. We still have to specify our domain controller IP. Target is the actual host where enterprise CA is located. In our case, it's gotham.marvel.local, and we saw it from netexec output earlier. We need the CA name. We also got it from netexec output, which is batman.ca. We need our template to find for Certipy find command, which is vulnerable 1. This is the template that's vulnerable to ESC1. UPN is the SAN, subject alternative name, that will supply to basically impersonate a user. In our case, it's going to be administrator at marvel.local, which is default admin account. And we also need a full seed for the user. And to get a full seed, there are a couple of methods. I think the easiest one from Linux is to use lookupseeds.py, which is part of imbucket. You just have to specify any user, password, and domain IP, domain controller IP. Hit enter. And here we have it. We got the seed for the domain itself. And we know that default RID for administrator is 500. So our full seed is going to be domain seed -500, which is what we have right here. So let's sequence the certificate and hopefully it works. Yes, I just already requested it before, so we'll just overwrite it. Yes. And we got a certificate for administrator, which is administrator.pfx. So now we can try to use it to authenticate the domain using administrator account. So going back to the Certipy wiki, all we have to do is use this command. Certified authenticate -pfx, which is going to be our certificate, and we need to specify the domain controller IP. It's going to be 192.168.75.132, and we hit enter. As we can see, it was able to authenticate using an administrator and give us the hash for that user. Let's try to use it to make sure it works. We'll do SMB as well. Specify administrator as our user, and we need to specify -h for the hash, and we only need the LM part of anti-LM hash, and we get pwned, which means we get full access, the main admin access to the DC, and we can use psexec or evilwinrm to remote into the system and do whatever we want. So we successfully escalated privileges from a user that had absolutely nothing to a full domain admin with just a few clicks because of misconfigured ADCS. So I hope this shows how serious this misconfiguration is and how easy it was to escalate to a domain admin. And this doesn't have to be administrator account, it could be any other accounts. For example, there's a separate account that's responsible for backups. You can just impersonate it and use it to log in and potentially destroy all the backups. So now let's look at the template and what it looks like from a GUI perspective and see how we can fix it. I'll log into my enterprise CA as domain admin. Here I have my templates right here. And here's our vulnerable one certificate. So, and let's just go back to the checks that we had. So first, enroll has to supply a subject. Just go to subject name, and this is the vulnerable setting. The preferred way is to build from Active Directory information. So if we set this, this will not be vulnerable anymore. Second one is extensible key usage client authentication. This might actually be needed, but this where it's set under extensions, application policies. We choose our EQs here. If your template needs client authentication, there's nothing you can do, but there are other ways to fix this vulnerability. So first one is subject name. Just change it to make sure users do not supply subjects. Or under issuance requirements, you can require manager approval. So right here. Yeah, sorry, just got lost for a second. But best way to fix it, if you still need this template and you need your users to supply subject alternate name, just make sure, and you cannot set manager approval for some reason, go to security and make sure there are no groups that can enroll into certificates that have all the users. So for example, domain users, if we remove from enroll, just leave it to read. They'll be able to read the certificate, but they won't be able to enroll and impersonate anyone. So if you need like a couple of accounts to be able to enroll into this template and just impersonate anyone, which it's not a great idea, but sometimes this has to be done to make sure the business continues to function. So just create a new group for those users and assign that specific group to be able to enroll and just limit the exposure scope. For general, it's best practice to not allow your users to supply subjects, and we can hit apply here. Let's remove our users from being able to enroll. So it's done, apply, okay. Now we just have to sync it, so I could demo it to you that this is no longer vulnerable. Okay. I have to sync the templates. Alright, that's good. And we'll restart the service to make sure it propagates. That's just to make it faster. After you change the settings, it just might take some time for it to propagate and be there. So now if we request all the vulnerable certificates, we should not see ESC1. We shouldn't see that template as being vulnerable to ESC1. So let's run this. And we'll look at our templates. So yeah, as you can see, ESC1 is gone. There are some other vulnerabilities which we'll cover, ESC2 and ESC3, but generally you can see that ESC1 is gone because client authentication is still there, but in our supply subject is false, which means regular users are not able to impersonate any other user. So that's it. We covered how to identify a vulnerable template, it was vulnerable to ESC1, how to exploit it, and how to mitigate it. Hope you enjoyed this video, and I'll see you in the next one where we'll cover ESC2, which is next privilege escalation. We could use the same template, and I'll also show you how to fix it. So thank you for watching. Please like, subscribe, and leave a comment below if you have any questions or would like me to cover something else. And I'll make sure to get back to you. All right. Thank you for watching. Peace.